Good day, my wonderful viewers. Welcome once again to Frequency Online Maths. Let's quickly solve this question. So this is number three. In number two, I think number two, we learned how to use this Laplace transform to solve a circuit, that's RLU circuit, transient what analysis, converting the that current flows with respect to what time, the rate of flow of current changes with respect to what time. You understand? So current flows with what respect to what time what interval. So we change it from time to frequency domain, and from frequency back to what time domain. That's the inverse Laplace what transform. So today we are going to use Laplace transform to solve this first order differential what equation. First order differential what equation. So in our next video, we will be solving second order differential equation. So we write our solution. Now we are going to take the Laplace transform of each and every function. That's Laplace transform of this, Laplace transform of this, and Laplace transform of what? These functions. So Laplace transform of x prime is what? S of what? X of what? S, then minus S of what? 0. That's the Laplace transform of this. In our previous video, I made a video on how to find Laplace transform of first derivative, second, third, and the rest. So now, Laplace transform of this x, just leave the 4 for now. Laplace transform of x is what? S of what? Is what? S of x of s. X of s. So that's the Laplace transform of what? S. Then Laplace transform of cos t is what? S all over s squared plus 1. So that's it. Now we put all these values in this equation. We are going to have s x of what? S minus x of what? 0 plus 4 times x of what? S, then is equals to s all over s squared plus 1. So we are going to have s x of s, then this one is 0. Sorry. So this one is what? 0. So we are going to have plus, this opening this will give us 4 s of what? X, 4 what? S of what? S is equals to s all over s squared plus 1. So we are going to collect like terms, sorry, factorize. So what is common here? S of what? S. You factor it out. This into this will give you s. This into this will give you 4 is equals to s all over s squared plus 1. So we divide both sides by s plus 4 by s plus 4. So when we divide, we are going to have s of s is equals to s all over s squared plus 1 times 1 all over s plus 4. Remember, if you have something like 5 over 2 over 3 over 4, this thing simply means 5 divided by 2 times, okay, 5 divided by 2 divided by 3 over what? 4. So changing division to multiplication, before we come out the 3 we go down. So that's the same thing we did here. So we are going to have s of x is equals to, this time this will give us s all over, this time this will give us s plus 4 s squared plus 1. Can you see it from there? Okay, beautiful. So we are going to have, s of x is equals to s, let me write it, all over s plus then s squared plus 1. So we are going to use partial fraction decomposition for this. Now, in partial fraction, you need to consider many things. First of all, check whether the degree of the numerator is higher than the degree of the what denominator. Let's check this one and this one, they are the same. This one and this one, degree of the numerator is less than what this denominator, this one. So you can do it. You can use partial fraction. But if the degree of the numerator is higher than that of the denominator, what are you going to do? You reduce it. You understand? But this one is less than the degree of what? This one. So you can do what? Solve it. So I hope you can see it well. So as I was saying, the degree of the numerator must be less or lesser than the degree of what? The denominator. Vice versa, the degree of the denominator must be greater than the degree of what? The numerator, in order to solve partial fraction. Now, another thing is we have many types of partial fraction. We take this partial fraction, as you can see, this is what? A linear partial fraction. This first one is a linear, and the second one is what? Non-linear. That's quadratic um quadratic partial fraction. Non-repeated quadratic what? Partial fraction. This thing is called non-repeated quadratic what? Um, fraction. Non-repeated quadratic partial fraction is this one. Now, this one is called what? Linear non-repeated what? Fraction. I hope you can see it well. So with this, we can solve this question. As you know that this one is what? Non-repeated linear what? Sorry, non-repeated quadratic factor. Why is it quadratic? Highest power is what? 2. Now this one is non-repeated linear what? Factor. If it is what? Repeated, it will be in this form. S squared plus 1 squared. That means this one will be repeated quadratic factor. You see it is repeating. It means that you times this thing in 2 times. So that's the things we need to consider in what? Partial fraction. So we are going to have a all over this s plus 4 plus b. Now for this quadratic non-repeated quadratic factor, it will be in the form bs plus what? C all over this s squared plus 1. So it will be in this form. Now we are going to multiply. We are going to have a s squared plus 1. That is this one times this plus bs plus c times s plus 4 is equals to our s, this. So it's not actually that is this one times this one. You can still find your what? LUC what? LUCM. So they are still the same thing. So in order not to waste time, we are just going to use shorter method. This times this times this. So we are going to have we are going to set this one equals to what? 0. So let's set it here. S plus 4 is equals to 0. Therefore, s is equals to minus 4. So we are going to use it. Our s is minus 4. So anywhere we see s, we put what? Minus 4. So minus 4 squared is what? 16 plus 1, 17 plus, as far as 0 is have come here, all this thing will what? 0 is equals to minus 4. Understand? Because minus 0 times this is 0 plus this 0 times this 0. So we have 17a is equals to minus 4 over 17 over 17. Our a is equals to minus 4 over 17. Now, we cannot say this one equals to 0 because is what? No repeated. So we are going to do the same thing here. So we have a s squared plus 1 plus b s plus c, right? Bs plus c then times s plus 4 is equals to s. In this one, we are going to do what? By comparison. So let's open the parentheses. This times this as squared plus a. Then this times this will give us, this times this will give us what? Plus b s squared. This time this will give us 4bs. This time this will give us plus cs. This time this will give us 4c is equals to s. So you can collect like them. Those with s squared should come as squared plus bs squared. Then those with s should come 4bs plus cs. Then those without any force should come is equals to s. So we can factor this out. A plus b into what? X squared plus, factor this out, 4b plus c s. Then these people that don't have frequency, mass is actually funny. There are some things like this happens in real life. Like, if you don't have money, see, this thing I'm solving now is real life. Okay, just take a look at this thing. These people now, they have people that have connection. See, these people, they have people that have connection. This as squared, bs squared, they have people that have connection. Then bs, cs, they have people that have connection. But this a and this 4c, they don't have people that have connection. So they will just tell them, I beg, stay one side. So these people that have connection now, their connection have landed them to this place. They bring food for them, they will eat. These people that have connection, their connection have landed them in this place. They will bring food for them to eat. Now let's take these people that don't have connection. Just see their, don't worry. When we compare them, you see this thing they will receive, the gift they all of them will receive. Then so we have a plus 4c. Now these people that have connection, mm, they will have 0s squared plus, these people, remember s is here, so we have 1s, then plus 0. See, these people that have connection, they have 0s squared. That their 0s squared is still money. But these people that don't have connection is typically what? 0. Automatic what? 0. My brother have money in this life, bro. Even in mass, they regard people that don't have money as what? 0. Can you imagine? Even in mass. Hey, Jesus. Okay, oh. This word no balance. So we are going to have, now comparing them, we have a plus b s squared is equals to 0s squared. The s squared we cancel, we have a plus b is equals to 0. Now comparing these people, 4b plus c s is equals to 1s. So cancel, we have 4b plus c is equals to 1. These people that don't have money, no need of comparing. So I can say a plus 4c, automatic what? 0. Right. So we have now, we can call this one equation 1, equation 2, and equation what? 3. And equation what? 3. So we are going to have, now remember we have the value of a. So from equation 1, do you see? They're even going to equation 1. They're not even coming to these people that don't have money. Hey, mass. From equation 1, the rich kids now, our a plus b is equals to what? 0. So our a is what? Minus 4 over 17. Then is equals to minus what? B. So automatically our b is now 4 over 17. You see? So let's go to, okay, as as the caretaker of this mass. I'm the person solving this math. Let me just go to these people that don't have money. Let me sympathize with them. So, oh yeah, A plus 4C. I know you don't have money, so I will make you a great nation. So, we are going to have our A is what? Minus 4 over 17 plus 4C is equals to 0. So we can multiply through by 17. When multiply through by 17, we have minus 4 plus 17 times 4 will give us 68C is equals to 17. So we have 68C is equals to 17 plus 4. So we have 68C is equals to 21. So we can divide by 68 by 68. So our C will now be 21. I hope you can see it from there. So we are going to have what? I made a small mistake here. 17 times 0 is not 17, is 0. So this boy wants to have money quickly by all means. So we have 0. So here will be positive 4. Here will be positive 4. So we are going to have 4 all over 68. 4 here, 1. 4 into 68 will give us 17. So our C is 1 over 17. Can you see it from there? 1 all over what? 17 is our C. Okay, let me bring it up. C is equals to 1 over 17. Okay, you can see. So our A is equals to minus 4. Minus 4 over what? 17. B is equals to 4 over 17. Right? Then C is equals to 1 all over 17. So let me clean this side. Let me take a snap first. So let me clean this side. So we are going to have, now remember, at this stage we got this at this stage. So we are going to have y, remember, x of s, that's the Laplace transform of what? X of what? T give us what? X of what? S, right? Now the inverse Laplace transform of what? X of s will now give us x of what? T. That's inverse is bringing back. You understand? So we are going to have, okay, let me just leave it. Let me clean it. We are going to have what? Now we are going to transform this x of s to what? X of what? T. So it will now be x of t. Transforming it to time domain. We have our A. Our A is what? Minus 4 all over 17 all over s plus 4. Then plus our bs plus c. Our b is what? 4 over 17. So we have 4 over 17 times s. Okay, let me write it so that it will be in the same distance. 4 over 17 times what? S all over. Okay, 4 over 17 times s all over s squared plus 1. Then plus our c is what? 1 all over 17. 1 all over 17. Can you see it from there? So we are going to have our x of t will be what? Now I can write this thing as minus 4 over 17 times 1 all over s plus 4. Let me put it in this parentheses. Then plus, I can write this as 4 over 17 times s over, okay, let me write it in this, times s over 1 times s over what? Okay, okay, I can write this thing as 4 over 17 times s over what? 4 over 17, then bracket s squared plus 1. Close it, because when you multiply this you are still going to get this. Okay, let me simplify it more so that you understand it. So this 4 over 17 is what? 4 times s over what? 1 all over s square plus 1. You understand? So this thing here is still the same thing with this. So if you multiply this, you are going to get 4s over 17 all over s squared plus 1 all over 1, which is 4s over 17 times 1 over 1 over what? S squared plus 1. You understand? Now, you know that this 4s is still the same thing as what? I can still write this thing as 4 over 17 times, I will shift this s to multiply this 1. It will now be s over s squared plus 1. It's still the same thing, because when I multiply it, I'm still going to get what? When I multiply this 4s by 1, I'm still going to get 4s. If I multiply this 4 by s, I'm still going to get 4s. So that's the trick behind it. So I'm going to have 4 over 17 times s over s squared plus 1. So that's the trick. When you multiply it, you are still going to get the same thing. Then plus, remember the over is still, the denominator is still what this? 1 over 17 times 1 over s squared plus 1. Let me write it where x of t is equals to minus 4 over 17 1 over s plus 4 plus 4 over 17 s over s squared plus 1 plus 1 over 17 1 over s squared plus 1. So our x of t will now be minus 4 over 17, the inverse Laplace transform of what? 1 over s plus 4, then plus 4 over 17, the inverse Laplace transform of what? S over s squared plus 1, then plus 1 over 17, the inverse Laplace transform of 1 over s squared plus 1. So our x of t will now be minus 4 over 17. The inverse Laplace transform of 1 over s, this thing, will give us what? Inverse Laplace will give us 4 over s minus 4. I hope you can see it from there. So I'm sorry, I'm using inverse Laplace transform of what? I thought this thing is s. 4, sorry. So the inverse Laplace transform of this is 1 over s plus 4 is exponential, because this plus is now, because it's plus, is now going to be minus 4 what? T. So plus 4 over 17. Then inverse Laplace transform of this is what? S over s squared plus 1 is what? Cos t. Then plus 1 over 17. The inverse Laplace transform of 1 over this is what? The difference between sine and cos is that cos have sine s on top, but sine have what? 1. So it will now be sine t. So this is our answer. So this is our answer. Thank you for watching and may God bless you. Don't forget to subscribe on our YouTube channel. Follow us on our Facebook page. Bye bye.